Okay, well, my name's Matt Cook, and this is going to be a kind of a brief intro into AWS Neptune. So this is Amazon new graph database, and we're going to briefly talk about why they made it, what it is, how it works, how you can get into the beta because this is currently a beta product. It's not in general availability yet, and then a few of the features that should be coming soon. So this link slide is also the last slide. If anybody needs the links, you'll have an opportunity to get it later. Okay, so graph databases have become very popular recently, and there are a lot of use cases for them, be it social networking, fraud detection, knowledge graphs, etc. And there are a lot of graph database products out there. So the question then is, why did Amazon feel the need to add to this, other than their general desire to have their hands in everything? Well, if you're familiar with AWS at all, you know that it's a very immersive environment. They have a lot of services that they offer. And if you are doing anything on AWS, even if you're not trying to use one of their specific managed services, you're going to interact with a lot of their services. And so when Amazon comes and works with you, they're going to see kind of everything you're doing, and they're going to kind of see how all of your workflows are working or not working for you. So as Amazon is working with these customers, they're seeing a lot of them implement graph databases, and they're seeing the same sort of trends over and over again. So what they're seeing typically is that a company will come in on some open source graph database, they'll do some POC, and it's tremendously successful, and they're very excited about it. They'll then try to scale that up to kind of an enterprise solution, and they'll find themselves unable to do it. Either the performance will suffer, or they won't be able to offer kind of the high availability and security features that they need. They'll see companies try to scale up in that way and run into either configuration problems, it's just a little bit too complicated for them, they have to bring in a lot of outside help to do it, or it'll become very expensive. Maybe they can do their POC essentially for free, but when they actually try to operationalize this and make it kind of enterprise ready, they have to license an enterprise version that tends to be extremely expensive and kind of cost prohibitive. So what Amazon is really bringing in their graph database is this kind of enterprise worthy reliability, high availability features. So what's really going to distinguish them, for instance, is that all of their data is replicated 6 times across 3 availability zones. So that's going to allow for even an entire availability zone to go down. You still maintain your read and your write capabilities. It allows up to 15 read replicas, and that's just built in. Again, doesn't require any sort of configuration on your part other than telling it how many read replicas you want. So that gives you kind of horizontal scalability on the amount of requests that you're handling. So with 15 large read replicas, we're talking about answering hundreds of thousands of queries a second with millisecond latency. Those read replicas are also balanced automatically for AWS, so you don't need to put any sort of load balancer in front of it to kind of route your queries. Amazon handles that for you. Encryption at rest and encryption in transit through TLS are both available to you. Encryption through KMS, so those are your customer managed keys that Amazon won't be able to read unless you let them. Also has backup and restore, even to time and point capabilities. So the system can automatically take backups, and you can configure quite a few ways to do that, as well as give manual backups. And you have the ability up to 24-hour to keep kind of a rolling 24-hour window in which you can back up to any specific point in that 24 hours. So if you had a lot of changes made today, you did something unfortunate in the last hour and lost some data, you can back up specifically to an hour and 1 minute ago and get back as close as you can to the state that you need to be at. Things like that read replicas also allow you to do some other nice failover techniques. First of all, failover is user configurable. So with these read replicas, if your head node goes down, you can specify kind of the order that you want your failover to go to. And then say you have a database out there with a certain size and certain performance characteristics, and you want to scale that up. One kind of clean way to do that would be to add a read replica that's of a much larger instance type with the kind of performance characteristics you want. Let it get caught up, let its cache get warmed, and then force a failover to the larger node, and then replace your other nodes at will. So first and foremost, Amazon is trying to make this kind of a high availability, durable product. When they had to get into the specifics of which graph kind of engines they wanted to implement or which sorts of endpoints, they talked to their customers and really kind of settled down to two. So they support the RDF framework and the Sparkle 1.1, and then they support Apache Tinkerpop 3.3 with the Gremlin imperative language. And when they were talking to their customers, something else they found about that was that even within the same company, they would have use cases kind of for both of those query languages, kind of both of those types of traversals. And Amazon simultaneously realized that their particular way of implementing this graph database didn't skew heavily towards one or the other, which is in contrast to something they found with a lot of the other graph databases where they might support both languages, but that was more, they supported the syntax of both languages and performance would skew heavily towards one or the other. So Amazon realized they had an opportunity here to kind of give equal support to both and not suffer those kind of performance limitations. Okay, as I mentioned, this is a beta product. So we just talked a lot about high availability and read replicas and all these wonderful features, and that's going to be fantastic when it's in general availability. Right now, of course, it's in beta. They can delete whatever they want, whenever they want. They can introduce breaking changes whenever they want. So absolutely not useful for production workloads at this point. We'll just have to wait on that. Okay, so we've talked a little bit about why they made this database and kind of what it's going to offer, but we still haven't really said how you're going to interact with it. What does this graph database mean when it's stood up? Well, what Amazon will do is they will stand up this database, and then they're going to offer you two endpoints. One of them is going to be a REST and WebSocket endpoint for Gremlin, and one of them is going to be a REST interface for Sparkle. When you create these databases, they're all going to be kind of wizard-driven just through the web interface. And you can see how they are adding these availability features. It's really more or less just kind of drop-downs on what you want. The wizard will help you as you're creating these databases. It will try to help build some of the infrastructure around them. For instance, your database is always going to be in a virtual private cloud. If you don't have one, it will try to help you create a default one. You're always going to need a few subnets. If you don't have them, it'll try to help you create them, etc. Even down to like the security group rules to allow your database to talk with different instances. One thing I will point out here, though, is a bit of an issue I ran into trying to use that default wizard. If you look up on the top left, you have a couple of security groups rules there, and you can see by the name, kind of this RDS launch wizard, that this was something that I just let it create for me to kind of see how it would work. That top rule for the inbounds on port 8182, it created that automatically for me, and that will allow anything in that security group to receive traffic from that location, and that location it gives is kind of the range that these graph database servers actually live on in AWS. It did not create that second rule for me, and that second rule, without it, I could not actually connect to this graph database. So did have some issues there, And we'll get into a little bit more about that here in a second. Okay, in order to load data into this database, we mentioned earlier that you have kind of two endpoints. You have a Sparkle endpoint and a Gremlin endpoint. You also have a bulk loader API, and that allows you to bulk load from S3 just through a REST command. In order to do this, you do need to have a VPC endpoint to S3. You need to have the permissions configured so that it has permission to read from that bucket. But it's just a REST command specifying kind of where the data is and what format. In terms of bulk loading data, for property graph, for Gremlin, it supports CSVs. You need to have your vertexes and your edges in separate CSV files with headers. And then for RDF, it'll support in triples, in quads, Turtle, and RDF XML. Okay. While this is in preview, you actually cannot connect to Neptune from outside of the VPC. You actually need to spin up an EC2 instance in the same VPC. That instance will be allowed to talk to Gremlin, and then you can connect to that instance through SSH, RDP, kind of your tool of choice. So that does offer a kind of a layer of annoyance in that you're going to need to either have this EC2 instance up all the time, or you're going to need to kind of reconfigure it every time you create it. So for instance, the initial process after spinning up this database might be bring up an EC2, okay, SSH into it, do all your updates, download your tool of choice, install it, configure it to your endpoint, and then you can start using it to query. Okay, some of the features that are not currently available in this, you know, we've mentioned they're really focused on kind of the availability aspect and security aspect. So some of the usability features aren't quite there yet. So these are configured as a single graph, meaning that you spin up a Neptune instance, you can have one graph on it. In the case of property graphs. If you are using like RDFs, then it does support named graphs, so you get a little bit of containerization there. But in general, you spin up one server, you have one graph. It does not support RDF inference yet. It also doesn't have features for versioning the graph across time dimension. So, you know, if you have a graph with preferences and maybe they liked pizza yesterday and they like donuts today, you're not going to be able to say, okay, give me these person's preferences as of yesterday. That's not a built-in function, so you would have to kind of work around that on your own. Federated Sparkle queries are currently disabled. The system is perfectly capable of handling them. That's more of a security issue while they're in beta. They just don't want to open that ability. Also don't have data constraints currently implemented. So multiple nodes on your graphs. If you wanted to have rules saying, you know, this relationship can only occur between these two nodes if certain criteria are met, you don't yet have the ability to do that. And it doesn't have any sort of time to live feature, so it can't automatically expire relationships yet like you can do in things like Neo4j. Okay, that's just kind of a quick overview, so I'll take any questions if anybody has them.
So on the versioning, if we were to use Neptune, how would you handle it? Would you be taking information that you found interesting for the graph database and writing it back to S3 and keeping like an audit trail, or how would you work around that?
Sure. So the question is kind of how I would work around the lack of kind of versioning on the time dimension. And there are definitely a number of ways to do that. You can certainly take backups at any point in time, and you can use those backups to spin up a new cluster. So you certainly could do it that way if you wanted to have your data for certain periods of time and then spin up, you know, the graph and see all the relationships as they were at that point of time. You could also do it by kind of adding more, kind of duplicate edges and nodes. So maybe you have edges for certain, time periods, population dates, end dates, if you had to do it that way. And probably definitely some options that I'm not thinking of. Yep. Okay. The question is Sonic's use case for a graph database. Honestly, from my experience, it was just to go out and look and see kind of what the technology has to offer. In terms of the general use cases that we have an interest in, definitely like a recommendation engine. And Jessica, feel free to jump in on this. I'm sure you have a long list of things you'd love to do.
Yeah, I mean, the lists are endless, but I know our most targeted use case for it right now is using it for the single view of the customer, to see all of the different relationships that the customers have with all the different activities. So did they make a purchase? Did they see media? Did they redeem a reward? And those relationships can get really complex, and we felt like a graph database would be a really good use case for that.
Is management identical to the other RDS business systems that they have? It looked identical, but I'm trying to see if there's like a big difference somewhere.
No, so the question is the management more or less identical to some of the other products that Amazon has, so like Redshift, et cetera, and they're extremely similar. Okay, thank you.